Hello friends, hope you're doing well. Welcome to the ninth episode of the geometry series. In this episode, we're going to specifically focus on the 3D shapes like cones, spheres, right circular cylinders, cubes, and so on. So let's get started here. Question number one. So we have a right circular cylinder here. Uh, the height of the cylinder is 8 inches. The diameter of the cylinder is 6 inches. And then from that cylinder, we are taking a piece out, right? So this dotted cylinder which we see in the middle, that's the portion which we are going to take out, right? So we're going to drill a hole here, okay? The density of this material is given as 490 pounds per feet cube, and we have to find the mass of this object, right? So first things first, right? So the density is given, and the volume is something which we will find out from the dimensions, and we have to find the mass of this object, right? So what is the relation between the density, mass, and volume? We know density is equal to mass over volume, right? So we got to know that the density is mass over volume. So in this case, density is given. We will see how to use it. Volume is something which we will find from the dimensions given, and then using density in the volume we can find the mass of the object, right? So having said that, let's get started and try to find the volume of this object. Now the volume of this object would be the volume of the overall cylinder minus the volume of this portion which we are going to drill out, right? What is the volume of a cylinder? The volume of a cylinder is given by pi r square h. Now you would be given these formulas in the reference sheet, but it makes sense and it helps us to kind of know about these formulas. And as I mentioned, there are not many 3D shapes in the scope. It's mainly right circular cylinder, cone, sphere, and things like that. Anyways, so the volume of a right circular cylinder is pi r square h. Now the outer radius is going to be 3 because the outer diameter is 6. So the outer radius is going to be 3. The height is given as 8. So the outer volume will be pi times 9 times 8, which is 72 pi, right? Remember, 6 is not the radius for the outer cylinder, 6 is the diameter, so the radius would be 3, and 3 square is 9, right? Let's find the volume of the, this is the volume of the outer, let's find the volume of the inner cylinder. Again, this is also a cylinder, this dotted portion, pi r square h. The diameter of the inner base of the cylinder is given as 3 inches, so the radius would be 1.5. So pi times r square times h, and this comes out to be 18 pi, right? So the volume of the object, right, without this inner cylinder will be V outer minus V inner, which will be equal to 72 pi minus 18 pi, which is 54 pi. So 54 pi is the volume of this shape, right? So we've got the volume, but we've got the volume in inches cube because all these dimensions are in inches, right? We got to note that the density is given as 490 pounds per feet cube. It is not per inches cube. So we will have to convert feet cube into inches cube. Let's see. So density is 490, but this is 490 pounds per feet cube, correct? We got to convert that into 490 pounds per inch cube, which will be equal to 490 pounds divided by 12 times 12 times 12 inch cube, because in 1 foot we have 12 inches, right? So we got to convert the density so that the units are matching. So actually speaking, the density would be 490 divided by 12 times 12 times 12 pound per inches cube, right? We can just use that formula given there. So density is equal to mass over volume. Mass is something which we have to find. The volume is 54 pi inch cube. So 54 pi inch cube. right? Inch cube and inch cube cancels out. We can cross multiply and we can get the value of m. In this case, the value of m comes out to be 48.08 pounds. I mean, obviously we can use the calculator for doing these calculations, but the more important point here is that how do we traverse this question when we have been given this 3D shape, this right circular cylinder, from which we have drilled a hole inside. The density of this material is given and we have to find the mass of this object, right? So what we did, just to reiterate quickly, we found the overall outer volume, we found the inside volume of this piece which is taken out. We subtract the volume of this piece from the overall piece to get the final volume, which is 54 pi. We use the relation between density, mass and volume. Density is equal to mass over volume. We converted the density into the right units and we use this relation to get the value of m. Question number 2. So we have a right circular cylinder given by this blue figure, and we have a sphere shown by this red object here, and the sphere exactly fits into the right circular cylinder. So from the base of the cylinder through till the top of the cylinder and on the sideways as well, right? And the radius of this sphere is, let's say, r. Okay, so that's the situation. So basically you have a sphere which exactly fits into a right circular cylinder on the sideways as well as from top to bottom. And in that situation you have to find the ratio of the volume of the sphere to the volume of the cylinder, right? That's all it's given, right? So again, the first thing which we need to understand is that whenever somebody is asking us the ratio, right, we don't need to know the actual values because things will cancel out by themselves. Let's see what I mean here. So the volume of the sphere is pi 4 over 3 pi r cube, right? So volume of a sphere is 4 over 3 pi r cube, where r is the radius of the sphere. Again, this is something which will be given to you in the reference sheet, but it helps in case you know about some of these basic formulas, right? Okay, the volume of the cylinder is given by pi r square h, as we had seen in the last question, where r is the radius of the base, right, and h is the height of the cylinder. Now in this case, the height of the cylinder is this, so this is your h. And if you see, because the sphere is completely directly fitting into the cylinder, right, we can say that h is nothing but equal to the diameter of the sphere, which is equal to 2r. So we have a relation right away that h is equal to 2r, where h is the height of the cylinder and which is nothing but equal to twice of the radius of the sphere. So we're going to use this relation here. Okay, so let's see, when we take the ratio of these two, what do we get? So what they're asking is volume of sphere over volume of cylinder, which is equal to 4 over 3 pi r cube divided by pi r square h, right? Obviously pi and pi cancel out. R square and r square cancel out, so you're left with only one r here. So this is nothing but equal to 4 over 3 r over h. Right, so far with me? Now we just saw that there's a relation between h and r is h is equal to 2r in this case. So we're going to use that. So instead of h, I can write 2r, because the height of the cylinder is nothing but twice the radius of the sphere in this case. R and R also cancel out and eventually you get 2 over 3. So just to quickly reiterate, right, whenever they are asking about the ratio, whether it's a geometry question or algebra or anywhere else, we don't need to know the actual values because things will cancel out, right? So in this case, for example, they wanted us to find the ratio of a sphere to the volume of the sphere to the volume of cylinder. We know these things. Volume of sphere is 4 over 3 pi r cube. This is pi r square h. We did the ratio. Pi cancelled out. R squares cancelled out. There was an r left on the numerator and there was an h left in the denominator. And in this situation, h is equal to 2r. When we plug in that, even the remaining r cancels out and we get the ratio as 2 over 3. Now next question. So we have a cube given here and each of these sides, dimensions of this cube is x, the volume of this cube is small v. And then we have a rectangular prism or a cuboid like this, and the dimensions of this object are the width is 4x plus 3, the length is 4x minus 3, and the height is 2x, right? And the volume of this rectangular prism is given by capital V, okay? And it is told that the volume of this cuboid or the rectangular prism is 30 times the volume of this small cube. So capital V is equal to 30 times small v. So that's the relation between the two volumes, and given these details, we have to find the value of x, right? So we have to find what value of x will make this situation true, that okay, you will have this cube, you will have this rectangular prism, and the volume of this has to be 30 times the volume of this, right? We know what's the volume of a cube. The volume of the cube is side times side times side. In case of a cube, all the sides are equal, so it's side times side times side. Basically width times length times height, which are all same. So x times x times x, which is x cube. So small v is nothing but x cube, right? Straight away. Same case for the rectangular prism. The volume of rectangular prism is length times width times height, right? So capital V is going to be 4x plus 3 times 4x minus 3 times 2x, correct? And we can expand this. Now this is obviously of the form of a plus b times a minus b, so we can use difference of squares to multiply that. So this is nothing but, it comes out to be 16x square minus 9 and then times 2x, which gives us 32x cube minus 18x. So this is the capital V, right? I'm doing nothing here special, just multiplying the width with the length, or length and the width and the height to get the capital V, which is coming out to be this. Now they have given us the relation that this entity is equal to 30 times this entity, so let's put it there. So 32x cube minus 18x is equal to 30x cube, right? Capital V is equal to 30 times the small v, right? We bring everything to one side, so we get 2x cube minus 18x is equal to 0. We take 2x common. So when you take 2x common, you get x square minus 9 is equal to 0. X square minus 9 you can factor as x plus 3 times x minus 3, right? So what are the solutions of this equation? The solutions of these equations are obviously x is equal to 0, x is equal to minus 3, and x is equal to plus 3. So these are the three possible values of x, right? But obviously, since we are talking in terms of the dimensions of a object, x cannot be 0, x cannot be negative, and hence the only possible value, the only meaningful value of x is 3, hence our answer is 3. So x is equal to 3. Just to quickly reiterate, we found the volume of this rectangular prism using these dimensions. We found the volume of the cube. We used the relation what they have given to us, that capital V is equal to 30 small v. So capital V is equal to 30 small v. We brought everything to one side and we solved like an algebraic equation. It's a cubic equation, so we are expecting 3 values, but out of those 3 values, these 2 are meaningless because x stands for the side of the cube, right? It can't be negative or it can't be 0. So the value of x is 3. Question number 4. So we have 2 right circular cylinders here. This is the first one and this is the second one. The dimensions of each of them are given as the radius of this one is r, the radius of this one is 2r, the height of this one is twice h, 2h, and the height of this is h. And the volume of this cylinder is given to be as 45 pi. Okay, and we have to find the volume of the second cylinder, right? So again, as we discussed in one of the other questions, that whenever they're talking about the ratios, we don't need to find the actual dimensions. We don't need to know the actual dimensions because things will cancel out by themselves, right? So let's do the same thing here. Let's write the volume of this in terms of r and h, right? We know that the volume of a right circular cylinder is pi r square h. Okay, so volume of the first cylinder would be pi r square h, where r is the radius of the cylinder, the base of the cylinder, and the radius of the base of the cylinder is r. So pi r square and h, where h is the height. And what is the height given here? The height given here is 2h, so it will be twice h, right? Or in other words, the volume of this first cylinder will be 2 pi r square h, correct? Now let's write the volume of the second cylinder. The volume of the second cylinder will again be pi times r square, where r is the radius of the second cylinder, the base of the second cylinder. The radius itself is given as 2r, so it will be 2r whole square times height, and the height is h. So this will be the volume of the second cylinder. We can expand this to get 4 pi r square h, correct? Now the value of this is given to be as 45 pi, right? 2 pi r square h, that itself is equal to 45 pi. So if we have to find the value of this, we can write it like this, right? 2 times 2 pi r square h, right? And this itself is nothing but the same, which is equal to 45 pi. So this will be 2 times 45 pi, which will be equal to 90 pi. So the volume of the second cylinder here would be 90 pi. It will be twice of the volume of the first cylinder. Again, just to reiterate, right, we don't need to have the actual values because they have given us the volume of the first cylinder. So we are able to get the value of this whole entity. 2 pi r square h is equal to 45 pi. And then when we are trying to write the volume of the second cylinder, it is also in terms of r and h. So eventually we get an expression. We get an expression of 2 pi r square h, which we write as twice of this guy, and this entity is equal to 45 pi. So 2 times 45 pi, which is equal to 90 pi. Let's take a last question here. So we have a water reservoir in the form of a cone, right? The radius of the base of the cone is 9 meters. The slanted edge is 15 meters, and there's water pouring into this reservoir, into this tank at the rate of 2.4 meter cube per minute, right? So this is the rate at which the water is flowing into the tank, and they're trying to ask, okay, how long will it take? How much time will it take for the tank to be fully full, right? So again, pretty straightforward. We need to find the volume of this reservoir. We have the rate at which the water is flowing, and hence we can find the time, how much time it will take for the reservoir to be completely full. What's the volume of a cone? The volume of a cone is 1/3 pi r square h. It is 1/3 of the volume of a right circular cylinder, right? As we saw in a few questions, the volume of the right circular cylinder was pi r square h, so it's 1/3 pi r square h. Again, this will be given in the reference sheet, but it helps if you kind of know them beforehand. You just plug in the values here. 1/3 times 3.14 times r square, which is 81, 9 square is 81, times the height. Now we don't know the height, but obviously we can use the Pythagoras theorem, right? Because this is a right angle triangle, this is 15, this is 9. So using the Pythagoras theorem, we get the height as 12, correct? And you can just simplify it. 3 times 27 is 81. So 3.14 times 27 times 12. So that will be the volume of this tank. And this comes out to be 1017.36 meter cube, of course, because everything is in meters. So this is the volume of this tank. The water is flowing at this rate. So obviously it will take 1017.36 divided by 2.4 meter cube per minute. Meter cube and meter cube cancel out. Obviously you get the time here, and 1017.36 divided by 2.4 is roughly around 428. So it will take around 428 minutes for the tank to be fully done. Again, pretty straightforward. They have given us the dimensions. We know the volume of the cone is 1/3 pi r square h. We use the Pythagoras theorem to find the height. We got the volume. The rate is given. It's in the same units, so we didn't need to convert the units as we had to do in one of the previous questions. And we divided the volume by the rate to get the time it will take for the tank to be full. Hey folks, hopefully you liked the video and you found the examples meaningful and useful. Keep practicing and see you in the next session. Take care.